In another question in mechanics, we had an axis like that and two forces. One of them was going in that direction and the other one was going in this direction, so along the x and along the y, and we label these properly. And then there was a third force that they gave us, which was in this direction, and they labeled that R, and they told us, hey, if x is 3 newtons and force y, which is in that direction straight up, is 4 newtons, then find the magnitude and the direction of R. And they gave us this angle as the direction, and we had to find that theta and that magnitude of R. So that would be impossible to solve unless they told us the next piece of information, which is vital, and it's something you should always see as very important clue, which is they told us the particle that's here and that's being submitted to all of these forces, it's in equilibrium. Equilibrium, which is a nice soft concept. Everything is in balance and delicate, so I have it in a bit of a salmon pink coloration. And so how are we going to solve this? So basically equilibrium means that it means that all of these forces in that direction are 0. It's not moving, it's in equilibrium, so it's not moving, so all of these forces have to add up to 0, and all of these forces going vertically have to add up to 0. So this is the big clue that we use to solve these problems, and it's definitely what we're going to use for this one. So let's see. What they've told us essentially is that this force here, 3 newtons along the x, has to cancel with anything else that is moving in this direction. Since this one is moving perpendicular to that, then these two don't affect each other, so we can ignore each. We're gonna do the math for this one first, and then for that one, quite independently, which is the whole use of these guys. And so let's do the horizontal first. So we say resolving in a horizontal direction, or in the OX direction. We have 3 newtons going one side, 3 newtons going one side. That has to equal the forces going to the left. Or let's do it differently. Let's say that 3, which is going to the right, plus all the other forces in that direction need to go to 0. So 3 plus this force here, and this force here is going to be R times cos of theta. That's this shadow over there. So R cos of theta, R R cos of theta. It's going to be this guy here. So that plus that, they need to equal 0. They need to equal 0 because this thing is not moving. So if by doing it like this, actually we could, yeah, I mean R is going to come out negative like that, but let's, since we're taking this theta here and that R, and that's the direction we're giving it, let's take it to be negative, because we can see already from the diagram that it's going to be negative, so I might as well put it here as negative already. So let's here say accept that this is going to be a negative there. So that's going to have to be equal to 0, and now let's resolve in the vertical direction. We have 4 newtons going up, so 4 newtons plus the vertical component of that one, but since it's negative it's going to be R sine, right? That's going to be sine, R sine of theta, because it's the opposite to the angle, so that's R sine theta, and this was R cos theta there, and R sine theta would be 4 minus r sine theta, because they're going in opposite directions, and that's equal also to 0. So now we can combine these two equations to find out r and theta. And since they are, so that's going to be simultaneous equations, so let's all write them in here. Minus r cos theta is equal to 0. We can subtract from that the other equation. I think you've done it like this before. You can also substitute. This is the same thing. I'll subtract this one, and actually let's not subtract them, let's divide them, because if we subtract them it's not going to work so well here. So the idea is to get rid of one of the variables, right? To find either r or theta, and the reason why I'm not subtracting them here is because r cos theta, when you subtract it, you add it to this, they're not going to cancel each other out. But if you divide them, something useful will happen. So just so that you understand what the concept of dividing two equations is, if I tell you that x is equal to y, they're identical, which is here we have something is equal to 0, and then I tell you that z is equal to p. If these two things are true, then you can come and say, okay, so if that's equal to that and that's equal to that, then definitely if I divide this by z, I'm going to have to get the same as if I divide y by p, right? It's like saying 2 equals p and 3 equals q. Then obviously 2 divided by 3 is going to be the same thing as p divided by q, right? So that's a bit of a better example. So hopefully you can see here the fact that you can divide two equations and it's still sensible. So the equivalent over here, since we can't divide by 0 because it's illegal, we need to first pass the things to the other side and then do it. So we have 3 is equal to r cos theta, and pass that to the other side, positive, and here 4 is equal to r sine theta. And now we can divide, let's divide this one divided by that one, because sine divided by cos is tan, and therefore we can simplify things. Also when we divide them, the r is going to cancel, so we can find the angle from there. So we have then 4 equals r sine theta, and we're going to divide that by, oops, well, it's very noisy downstairs. I don't know what they're doing. Somebody's doing some aerobic or something. Okay, so I've waited a bit until they've finished downstairs, even though to you it won't look like that. Let me get rid of this first. So we're going to divide those two equations, but the way that they would look if we divided them, it would just be the numbers on the one side. So I said I was going to divide this one by that one. So the 4 would be at the top. So you have 4 divided by 3 is equal to r sine theta over r cos theta. And this is useful for two reasons. One of them, we get rid of the r, so we can now solve the equation only in terms of theta. And second, sine over cos is tan theta. And that's equal to 4 over 3, so then we can get our theta from the inverse tan of 4 over 3. And if we do that in the calculator, we get shift tan bracket 4 divided by 3 close bracket 53 degrees 53.1 degrees. That's our angle. So what that, I need to go to the diagram to see what that actually means, and this is theta, so this guy here is what we just calculated, and we still don't have r, so we can now go and say, okay, let's have a look at any of our equations, and we can use that to find that now. Well, we know 3 is equal to r cos theta, so we can use that one. 3 is equal to r cos theta. So therefore 3 divided by cos theta will be equal to r, which is divided by cos theta both sides. And so 3 divided by cos of the angle we just worked out, cos of the answer is equal to that. So 0.6, so 3 divided by the answer is 5, so r comes out to exactly 5 newtons. So then we have our answer, which is that R would be equal to 5 newtons, and this angle here would be 53.1 degrees. 53.1 degrees. Okay, so hopefully that made sense. We just did it by saying that everything was 0. Don't worry, when we do a bit of practice, these things of either adding simultaneous equations or subtracting them or dividing them, they will get much easier than before. So just as a little summary, what we did, we had 3 forces at the beginning, which were, one was like this and one was like that, and then there was a third one like that, and they gave us this force and they gave us that force, so we had all of that information, and then they asked us for this third one, so that we need to find that. We needed to find this angle and also the magnitude of that, and we were told that this was in equilibrium, otherwise it would be impossible. So if it's in equilibrium, then we knew that the movement in this direction was 0 and in that direction was 0 also. So we did equations for those two being 0, which were these two, and then we looked at them and we said, okay, how are we best gonna be able to solve them? We can't really add them or subtract them because we're just gonna have a mix of sines and cosines and they won't cancel so much. So the best thing there is to then divide, because then the r's will cancel with the r and you're left with a sine over a cos, and that's a tan, and you can solve for theta and then put it into any of these two to find your r. Hopefully that makes sense. You'll do quite a lot more practice with that, and it'll be fine. Alright, so thanks for watching, and I'll see you in the next video.